So I hope you had a good weekend. We have 3 more sessions together, okay? Today, tomorrow, and on Wednesday. And we have different things we can do and we will do. We don't have time to do everything, but we can try to push forward, that's for sure, no problem. So if I just summarize briefly, I'm going to share my screen. So let me see. So I should share this one. And I want to show you this. All right. So what we did last Friday is I told you about text mining and text curation. And I told you that text curation is what you need to do before starting to run various analyses of your documents. So basically what we did during the last lecture, I told you about text mining. I told you of some possible applications, and there are quite a number of them actually. I told you about some ethical considerations. I told you then where you could find some sources for text mining. I told you about Project Gutenberg for the books online, books without copyrights, mostly because they are now in the public domain. I told you that you can actually access all the books from R with a special package, Gutenberg R. I told you that you can get Wikipedia, and I told you about this, which I'm not sure you have access to at your center, but there are some databases, Factiva, Europress, Wise News, and I guess maybe a few others, but I know the first 2 ones. And these ones, they contain news articles from many different newspapers. So you can do searches, and then you can collect possibly quite a large number of documents, and then you may analyze them. So these ones, you may check whether some of you or all of you have access to them. That I don't know. It costs some money for the university to have such databases accessible. So I told you, you may also collect from Twitter, and I didn't tell you about that, but there are also tools, packages, so that you can easily download tweets from R and of course from Python or other languages. That is not something very difficult. And you can do web scraping, but this requires further skills in how to clean a document. And finally, I told you about regular expressions. And this is something very well known when you process, when you clean text. And regular expressions, or regex for short, they are basically used to search various patterns in a text. And that can be useful when you try to detect various things, when you try to clean a text. There are different options here that may be interesting for you. So that's what I told you last time. And then if you want to practice with regular expressions on R, what you can do is rely on some what we call cheat sheets, and they are for different things. But that's just one example, there are different ones, but this is such a sheet for regular expressions. Okay, so you have different functions you may use, and then you have explanations of how you can start for things at the start of a string, at the end of a string of characters, at the beginning or the end of a word. You can have something that matches 0 times, 1 time, etc., etc., etc. You have special characters. There are a number of things that you should know if you want to use regular expressions. So I showed you this, and then what I did is that I gave you some patterns, some exercises to start to practice with regex. So if you check in the Google Drive folder, let me share that with you. All right. So in the Google Drive folder, you can find a small R script here, downloading a book with Gutenberg R. That's something I showed you last Friday. That's something you may use to download books and there are explanations in the code, so you may try to apply it. And then I created two folders. There is one folder actually which I won't get into, but in this folder I just uploaded 3 PDF files that I've been using to teach really the foundations of R to students here. Students in R who have no background in R at all. So if you check these files, if you feel like you are really new to R, and what I do is then, of course, quite difficult, maybe likely too difficult, you might check this to learn more about the basics of this programming language. But this is for your consultation. I don't use this right now. But I also created activity number 2, regular expressions, and there, so you have some activities that I ask you to do. So I ask you to try to write the regular expressions to do this or this or that. So I gave you a number of them. So I hope some of you, at least you tried by yourself, and I can show you the answers. And then I have something that we can do now as well, is how to experiment with regular expressions, but directly in R. So I have an activity that relies on the text file and its content, of course. And then I have another R file that you might use so that you find some questions and you try to answer them and you try everything by yourself. So that's everything we did last time and what is available. So I hope it makes sense. What we can do now, and before I move to other things, and then later I will tell you more about classical approaches in text mining later today. I can see there is a message. Okay, I will try to address that. What we can do is try to spend a little bit more time with the exercises I gave you on Friday, and so that I can see if you want to tell me what you tried and go through the corrections with you. There is this question. If you check this thing, you see that we have the hat that appears, that can be used for 2 different things. It can be used to mark the start of a string. So that's if you want to look for something, a pattern that is at the start of a string. But you can also use it if it appears inside square brackets to say that you want a search pattern without specific characters. So you can say that you want specific characters, but you can also say that you want something without specific characters. Then in that case, you may use the hat inside the brackets at the first position, and then that means not. Okay, so hat without brackets, not following an opening square bracket, then that means beginning of line, and if it's after, then that means not this or that character. Okay, all right, good. Okay, there are 15 people. Are you with me? Do you have any question before we move to the activities? General questions, anything you'd like to ask before I move to the next part? Are we good? If I don't see anything, of course, I will assume that you are okay. The answers I have not yet uploaded because otherwise you check directly and you don't try. So of course I have the corrections. I'm going to do that now. And then of course, then I will upload it. Okay. So that's here. So everything is here actually. So if I share this, so you should be able to see my screen. This is what I sent you. I uploaded on Friday, experimenting with regular expressions. I told you about the cheat sheet. Once again, you can find it in the Google Drive, and you can use this document to find how to build such patterns. And then I started to ask you something like this. What is the regular expression And here it can be for different purposes. So I don't ask you to write exactly the functions in R, but I ask you just to give me the search pattern, the regular expression itself. So you may use it to detect sentences, to locate something, a pattern somewhere in a string of characters. You may use it to modify a string of characters, etc., etc., etc. So I ask you first, how could you detect all the strings of characters, of course, which start with either Elizabeth or Mary? Have some of you tried to do that? And then could you type what you would like to propose for this regular expression? Start with either Elizabeth or Mary. How do we do that? Is there anyone? Did you try? Did you try and succeed? Did you try and fail? You didn't try? All right. Okay. If you have this one, it's nearly okay. Although here there might be an ambiguity, but that's good, nearly there. So here, if we want something at the beginning of a string of characters, we should use the hat, as we have discussed just before. And then we hesitate. We want either Elizabeth or Mary. And that's why we use a pipe. We write Elizabeth, then we write pipe, and then we write pipe is the vertical bar. I call it pipe, but you could call it something else. But yeah. And then Mary. Here, the only ambiguity maybe is that the program could interpret this as either something that starts with Elizabeth or which contains Mary, but not necessarily in first position. So what can we do to drop the ambiguity here? Here, that could mean starts with Elizabeth, maybe, or Mary, but Mary anywhere. So how do we have the hat apply to both elements? We can do something quite simple, which is okay, nearly there, but square brackets have a specific meaning. So indeed, we need to put brackets. It's just that we should not put square brackets, because if you put square brackets like this, it will look here at the beginning of a sentence for all the characters inside the square brackets. And the pipe, I think, would create a problem maybe inside this. So not these brackets, just the round one. Okay. So then you say at the beginning, I want either Elizabeth or Mary. So you will get all the strings of characters which start with either of these two words. That's the first thing. How do we check? Good. Yeah. How do we get now a string of characters which starts with a vowel? So not Elizabeth or Mary, but A, U, I, A, O, a vowel in the first position. In the first position of the sentence. Okay, not bad at all. This work on your side. Okay, so if we check, we see that we have \\, lowercase b. So if we go and check here, we will find that this in anchors, lower backslash backslash lowercase b is an empty string at either edge of a word. I guess, yes, if you tried, it works. Maybe we don't need that. Maybe we can just have, like before, we could have the hat in first position. But then you are right. If you want to have any vowel, and here you used lowercase or uppercase, then you can just write hat, square bracket, and then a, e, I, o, u, a, e, I, o, u, and that's good. Do we need necessarily to put the AZ afterwards? We can try that. And the plus means matches at least one time. So here, actually, if you write something like this, if you write this, with a plus, you will actually require that there is at least one letter after the initial vowel. So a string of characters which would contain only a vowel would not be returned. So if you want to have no specification for what comes after, the one where you only have the vowels in square brackets, that's enough. If you want to write all the letters of the alphabet, lowercase or uppercase, there is actually another shortcut. This means all the letters, uppercase or lowercase. So that should be the same as this, but this is a bit more convenient to write. Okay. All right. If you want to say, I want the sentence to start with something else, and then you provide the number of letters, what will you need? What is the device you need? Sorry, you need to use this time. You don't want something which starts. Sorry?
Question?
Sorry, I didn't get it.
Oh my God. Do you get me very well? I don't know if my microphone is working. Oh my God.
Okay, I'm not sure I understood. Sorry, because the sound was not very clear. So if you want something that doesn't start.
Yes, Professor, I have a question.
Yes.
Yeah, okay. I don't know why for my side, this regular expression, the one I type in the chat, it returns 0 character from my side. I don't know why. And even me, it is the one I was supposed to write, but to give me a 0 character.
Okay, so I'm writing down, and we are going to try in R after that. Okay.
Okay.
We can try afterwards. Is okay. So if we want something other than a number of characters, what do we need to use? Rather than using only the square brackets, we need to add something, which is another hat inside the bracket. So here, you can see the letter one. Start with something other than, then you use a hat, a first hat here to mark the beginning of the sentence, and then you provide all the characters you don't want as a starting point, and then you provide the hat inside the square bracket to mean anything but these characters. And if you do that, then you get what you want. Now, if you want something that either start or end with Elizabeth, once again, you are using the hat. You need to use the symbol for the end of a sentence. and you need to offer the two options. So what you can do is to say, okay, I want either Elizabeth at first, or I want Elizabeth at the end. And then maybe here you could omit the parentheses, but just to make sure you can add them in case you are not sure. I didn't try without the parentheses, but this will work. So either start or end with Elizabeth. You use the pipe for like the operation or, and then start or end, you use the hat or the dollar respectively before the word and after the word. So that's how you get. Yes.
There is two things. You can look for starting of the line or starting of the word. You need a word that starts with either, let's say, E or other case, you may need a line that starts with E or maybe Elizabeth. What if you want to express a start of the word, not a starting of the line?
That's the problem here. We need to be careful indeed. So here, all my questions, they are related to strings of characters, okay? So if you have a string of characters, the hat and the dollars, they refer to the beginning and the end of this string, okay? That's something easy to check for R or for other programming languages, okay? But now, let's say that you have something like this. Tom came back home. He was very tired. Now here, you have one string of characters, but then you have two sentences inside the string of characters. So now let's say that you want to locate things at the beginning of sentences and not strings of characters. If I understood correctly, you cannot use the hat or the dollars only. You need something more than that. You need to be able to specify what can be the end of a sentence. I would say that the end of a sentence could be something like a dot and a space, or a question mark and the space, or maybe an exclamation mark and the space, or maybe 3 dots, or maybe there is something else, but that should be it. So you need to use these things, and the regular expression will be more complex. Also,
maybe.
Yeah.
Oh, no, that's true what you're saying. That is when I write regular expression like this, and I have like 2 sentences started by Elizabeth. My regular expression was returning first sentence only.
Yeah. Yes, because if you use the hat, you will get, if you have something like this. Elizabeth is tired. Elizabeth wants to sleep. That's a single string of characters. But if you look for something like this, then you will only return the first Elizabeth, because the second one is not at the beginning of the string. So if you want to try to detect things at the beginning of sentences, you need something more. So you could have something like, but it may not work completely, but you could have something like this. Either Elizabeth at the beginning of the string of characters, so that would be like this. Or you could say that you want Elizabeth, but after something. But the problem is how you write the after something is not so easy. That's where you need to look. You need to use what you can see here in the maybe I can make it bigger. Here, bottom left corner, you have lookarounds and conditionals. So you could ask for a look behind, and just before you would say that before Elizabeth, you want the end of a sentence. That's something you can do, but that's something quite tricky. So if I write it, I think it should be something like this. So that would be something you want to look before. So something like this, and before what you would like is something like a dot, an exclamation mark, a question mark, and then you would like to have a space or something like this. So then you would collect all the Elizabeths either at the beginning of the string or Elizabeths appearing just after a dot, a question mark, or an exclamation mark followed by a space. That would be possible to do it. It works. Or maybe it can be a small mistake here, but that would work like this. But of course, this is more advanced regular expressions. But something like this would work, I guess. Yeah. But okay, this is advanced regular expressions. But if you practice, then you can totally write stuff like that. It's okay. What you can do is maybe also you can format your text at first so that each line is basically each string of characters is one sentence. And then that kind of make it easier. But yeah, that's something you could do. But this is more advanced. This is what we call lookarounds. Okay. If we want something that starts with M or end with exclamation mark, once again, we need to combine everything. So either we say, okay, I want this or I want that. If it ends with a question mark, then you can say question mark, exclamation mark, sorry, and dollar. That's what you want at the you want final exclamation point mark. If you want to start with M or N, start means hat. So you would need a hat. And if you want M or N, one way to do it is to use the square bracket and write MN. If you write this, either you start with M or N, or you end with exclamation mark. That's how you could write it. Then that should work. How do you start with either the personal pronouns he or she? What would you write here? How would you have, or how would you detect all the strings of characters which start with the personal pronouns he or she? Given everything we've said, what would you try here? There is a small trap here. Please give it a try. Anyone? We know the hat. We know how to say this or that. How do we do that? Okay, I like this. You will get all the string of characters starting with, oh, okay, nearly there, but don't put the square bracket. So you could write, if I'm right, what you want to say is that is this. Either she or he, or if you want to be careful with even more things, you could write she or he, that would work the same. What is the danger with writing something like this? If we are looking for the personal pronouns he or she. If we write something like this, this sentence is not very correct grammatically. But if you would write something like helicopter as the first word of your string, then using the former expression, this would be selected because helicopter starts with HE. And then maybe you could think of other words starting with she, like sheep. So in that case, you would detect the search pattern would return a positive result. However, it would not be the personal pronoun. So what could you do to prevent this problem? What can you do to prevent selecting sheep or helicopter or other words so that you can focus on the personal pronouns? Any idea? Okay, I think I get the point. So, okay, there are two things here. If we would write exactly this, and then we just say we want a space behind it. If we would just add a space that you cannot readily see here, what is the problem? The problem is something like this. He who did this, okay, let me try to, he who commits sins shall be punished. Okay, something a little bit religious, sounding like something from the Bible or something like this. He who commits sins shall be punished. In that case, he is a personal pronoun, but then you have a comma. You have some sentences that could be like this. So if you look for he plus space, you would not select such a sentence. So I think Jesse, you are on, you have the idea. I'm not sure, but I think what you mean is that what we should do rather than entering space or comma, what we can do is use this. Because when we use backslash, and greater than, this thing means that that should be the end of the word. And in that case, whether it's a space or a comma or a dot or whatever, then that will work. So with these examples, I just want to show you the kind of small tricks, the small things you need to be thinking of when you do this, what you need to think of. If you want a word, then you can use the elements to say the beginning or the end of a word. Then that will be okay. And then either start with the personal pronoun we or end with Elizabeth. Then you kind of need to mix these different things. So what can you write? You could say, okay, I want to start with we, but I want we to be a word. So after we, I want something that is not yet another letter, like weed or something like that. And then if I want this or something ending with Elizabeth, then I just say, okay, Elizabeth comes at the end and I use the pipe in between. My string will start either with we as a word or will end with Elizabeth. Do you see how I use these elements like the start, the end, the pipe to say or, beginning of a word, end of a word, the square brackets, how we can combine these elements to create more elaborate search patterns. Does that make sense? You definitely need to practice to get it right. But it's really about the logical combination of these elements to achieve the goal you want. Are you with me on this? Does that make sense? I don't say it's super easy, but I would say it's not super hard. If you practice, then you get it. It's not very fancy mathematics or anything like that. It's just a way to look for special things in your strings of characters. Any question, or is it good? Okay. Okay. Yeah, you need to practice more. Of course, remember also that if you want to like detect personal pronouns he or she, at the beginning of a sentence, you may have uppercase, right? So you see here, for instance, I have made it a bit more sophisticated. At the beginning of the sentence, either it's lowercase or uppercase h followed by e, or it's lowercase or uppercase s followed by he. And you could actually write it in another way. That would also be possible. But that include sentences starting with either, shall be, etc., etc. So that's how we could do it, and we can combine the different things. How do you find, maybe we try just a little bit more. How do you find the regular expression to detect all the words which end with E? How would you write something like that? All the words which end with E. Anyone? Just give it a try. That's how you practice. If you just wait for me to give you the answer, then there is no practice. If you don't practice, there is not so much learning. This is really like about trying again, and then eventually you get it right. For the end of a word, we have seen that we have this one. That's the end of a word. So maybe what we could write is EE, and then we write the end of a word. Is it okay to write something like this? If we want to find the words which end with E. Like in a sentence like this, I'd like to see the C with EE and then EA. Is it okay if I use the expression I wrote just above the sentence? Is it okay, or do you spot a possible problem? Okay, I think you are, yeah, you are not far indeed. If we want to detect the whole word, we cannot just write this one. Otherwise, we will miss the letters before. We will just get EE and not C with the S before. So indeed, we need to say that we would like the letters before, but these letters may be anything. So what we could write is something like this. Beginning of a word, then anything, any letter a number of times. So you could write like this, any letter, and then if you check the sheet with all the explanations, you see that you have something like a star, and it means matches at least zero times. So you could write like this, and then you could write EE, and then you could say, I want the end of the word. That's one way of doing it. The difference with what, I'm not sure, what is your first name? Is it Longin? How, or is it Dusen Geyezu? I'm not so sure. I'm sorry. If you write something like this.
Yes, can use a Longin.
Longin. Okay, Longin. Okay. If you, that's a good idea. If you use this one with a dot means anything except the end of a sentence. So the difference between the two is that if you have something like, I don't know, if you have something like this, I like I just write something, just weird, okay? I like the string 8BE, 8BEE, okay? This one, the first expression, it will not work. Because you said for your word, you don't want digits inside. You just want letters. But if you write you are okay with anything inside, 8BEE, something like that, that will work. Or like if you would have all right, okay. Maybe on Twitter, people, they like to make things shorter, okay? So to 4C something, they would write like with the digit number 4, 4C. Then 4C would be selected with when you use the dot, but it will not be selected if you say that you want a letter. You want letters before EE. That's the difference between the two. So once again, these are small differences, and so you will get nearly the same selection, but in some weird cases, then that could be a bit different. Now, if you want the word to end with EE or AL, sorry, then you can just start to use the same thing that we wrote before. But then if you want EE or AL, then you are going to use the pipe just to say or. So you can write like this. It's the same as before, but you replaced EE by EE or AL. That's the difference that has been introduced. If you understand this, you should be able to write how to look for all the words which start with lowercase r or uppercase R. It's just a matter of using these different elements we have seen, but in a different order. Anyone wants to try something? Just give it a try. A word which start with lowercase r or uppercase R. It's very logical. So what would you try? If we start, if it's the beginning of a word, then we should use this one. Then if we want to say we want small r or big R, we could write like this. We could use the square brackets, R or R. And then, so Longin, if you write this, you will get all the words which end with lowercase r or uppercase R, not the words which start with lowercase or uppercase. So what we need to do is just reverse the order of the elements inside. So first we write R or R, and then we write any letter 0 times or more than 0 times, so any letters you want, and then comes the end of the word. So we had just exchanged the place of the component. What we could do also, another way to write this, which will work just the same, is to say, to write it like this. Rather than using the square brackets, we just use the pipe. So we just open. Oh, sorry, there is a small mistake in my closing parentheses. So it should be this one. Here it's all right. I just use the pipe, so big R or small r, and then a number of letters, possibly zero actually. So that would do the trick. And then you can combine beginning, the end, start with a T and end with ST, like a word like toast, for instance. Then you just need to combine everything we've done before. So at the beginning of the word, we want T, and then we want any letter a number of times, and then at the end, we want ST, and then we close the word. That will give all the words which start with T and end with ST. If you want to end with a consonant, a way to make it simpler, so you don't have to write all the consonants, is you can use the hat inside the square bracket to say anything but these characters. So if you don't want the word to end with a consonant, if you want the word to end with a consonant, it means you want the word which ends, but not, oh, sorry. Yeah, you want a word which ends, but not with a vowel. And therefore, you will get all the consonants. If the word must contain EE, could be at the beginning, could be at the end, but could be also in the middle of the word, then you say, okay, beginning of the word, end of the word. In between, I'm looking for some letters before, maybe, maybe not. Then I want EE. Then I want possibly some letters after that. But here, you could have nothing here, or you could have nothing here, or you could have nothing here and nothing here. In that case, the word would just be EE. Doesn't mean anything, but it's okay. So you just say, maybe there are some letters before, maybe there are some letters after, but at some point I want EE inside the word. So that's why I have this. So it's just combining everything again and again and again to get what I want. It's very logical. It requires practice, that's for sure. Does that make sense? Or do you have any question? Longin, it seems you have more experience, so it's good. What about the others? Chantal, Florence, I remember Agnès from the previous times. and of course, everybody else. Is it okay? Trying, okay? Okay, Muhammad. The thing you need to be careful of is that they are, I mean, what you can very well see is that there are some characters which play a special role, okay? The dot means any character. Star means at least 0 times. Plus mean matches at least 1 time. Question mark means at least this or that. Okay? So the point is that these characters, we call them meta characters. They play a special role in the regular expressions. But what if we want to detect dots in our strings of characters? That's what is explained here, that you need to escape the characters. That means that if you want to look for a dot, what you can do is do something like this. Backslash, backslash, dot means you are looking for the character dot. For instance, you could look, if you would look for something like this, this regular expression would help you to find all the Mr. with a dot, so everything written like this in your strings of characters. If you write this, you will not look for Mr. You will look for everything which starts with uppercase M, is followed by R, and then any character except the end of the string, like except the backslash N. So that will return not exactly what you want. That will return other things. And it's the same if you want to find all the questions in your sentences. That means all the strings of characters ending with a question mark. Then what you could do is write something like this. I want all the question marks at the end of a string. So if you have several strings you are paying attention to, you will detect all the strings which end with question mark. But here you need to escape the characters. You need to use backslash, backslash in order to look for the character in the strings. So that's something that you need to be aware of in a way. That's something that can happen. Let's say that you are working with news articles and you want to detect all the questions that were asked. Then if you look for question marks because they indicate questions, then you should use this escaping so that you can find all the sentences like this. So this is what is explained on my slide. So if you want all the sentence which end with him plus dot, then you can write it as it is in red. If you want something that end by anything but a dot, you can write it like what you see here. You say, okay, square bracket with hat, so anything but what is inside, and inside you have written dot. The only thing here is that when you use squared brackets, you can drop, if it's inside the square brackets, it's okay to just write the dot. That will work. But that works only inside square brackets. Otherwise, it won't. And then once again, you can combine everything. You want a string to end with a consonant followed by a question mark. So at the end of my string, I want a question mark. And before, I want a consonant, which means I don't want a vowel. Then you can say before is everything but a vowel. And maybe here, if you want to be complete, you could also exclude here. Maybe we would also exclude the digits. I have not done it here, but maybe we should do that. That would be maybe better. And I'm writing this so that I can correct it for you. So I will correct that. If you want to make it right here, maybe it's best to write that you don't want any digit as well. That seems better, more complete. And then you have also for the quotes, then you can use 1 backslash. That's for a quote. So that would be a string which starts with a quote. And then if you want a double quote followed by a vowel or a digit, well, then I wrote a quote followed by either a digit between 0 and 9 or a vowel. And I consider the lowercase and the uppercase vowels. Once again, I combine different things. Okay, I see if I want to tell you something else. All right, I think that's quite good for now. So then it goes on. Then you can learn other symbols, all the regular expressions which contains 10 letters, which contain 10 or more, either 2 or more consonants. When you want to give some numbers, a number of times things appear one after the other, then you can use, if you check the cheat sheet once again, what we call quantifiers. And that's where you can choose matches between n and m times, like matches 2 or 3 times, or matches at most 5 times, or at least 2 times, or exactly 3 times, at most 1 time, etc., etc. You can really use this. Let's say that you want to find all the sequences of at least 4 digits, then you can use something like this. Okay, I want a digit, and I want that at least 4 times. That's how you can write it. That would be a digit repeated 4 times minimum, but maybe also 5, 6, 7, 8, 9, 10, and so on and so on. So contains 10 letters, all the words which contain 10 letters, and there should be no S here. Lowercase or uppercase. Start of the word, same as we have done before. We start the word, we say, okay, needs to be the beginning of a word for our search pattern. Then any letter, uppercase or lowercase, then it should be 10 times. And then that should be the end of the word. Then it's going to return a number of words, and all these words, they will have exactly 10 letters. And with 2 or more consonants, beginning of a word, end of a word, as again, then a number of letters, uppercase or lowercase, and for the end, consonants. So we can say, okay, we don't want any vowel, and then we want this twice or more. So that means 2 or more consonants. And here I could add that I want to avoid the digits in case that could happen. Maybe not the case actually. So I have combined all my symbols in yet another fashion. So since I've already spent 1 hour on this, you can, I advise that you check the final ones, okay? I gave you yet some others. You can use this to detect IP addresses. You can use a regular expression to detect an email address. You can find a lot of different things, okay? So this I can upload and then you can check. Is it okay? If you haven't tried, maybe I don't need to go through everything. It may be easier that you check by yourself so that I can move on something else to something else. You can do that. And then if you check the folder in the Google Drive, so that's this one, regular expression, you will find that there is an activity that you may do. This is how to experiment with regular expressions further, but this time using R. And everything is available in the Google Drive. The text is actually the novel Frankenstein by Mary Shelley. So actually in here, you have Frankenstein.txt. And if you open this file, what you will find in this document, this is what you will find. You will find the whole story of Frankenstein. Okay, Jesse, I'm coming back to you. Yeah. You see, it's the whole text, it's the whole story of Frankenstein. And the way I made it, actually, I used some regular expressions so that each line, each string of characters, when you read it, will be exactly one sentence. So it's quite long. I mean, there are a number of lines, and you can see all the sentences of the novel. So the activity is about loading this in R. And then try to answer different questions about the text. So you can, there is an R file that I also created for you that is available. And if you check this R file, you will load the story inside in R. And then there are a number of questions that you can try to address. So this is the code that is available on the Google Drive. You load a package that's string R. Actually, you don't really need that. Actually, I don't really use it, so you could remove that. I empty the memory, and then I use the same thing I've used before. If you remember, I tell, okay, I want to load Frankenstein. This is the folder where it is on your computer or in my computer. And then I use this function file and this function read lines, what I had shown you last week. And if you do that, basically you are reading the book into R. So I don't know why it takes a bit of time right now. Okay, it worked. So then if I check book, actually there are many, many lines, but you see each string of characters is one sentence of the book. And then rather than just writing down the regular expressions, you can actually try to use the different functions in R like grep, regexp, regmatches, gsub, all the functions which you can see here in this part of the Google Sheet, all these functions, you can use them to try to investigate the content of the novel. All these functions you may use. Some functions, they are basic functions in R, like grep, grep else, regexp, all these ones. But you see that you also have another package that they recommend, which is the package string R. And then you can achieve the same result with slightly different functions like str detect, str locate, str extract, str replace. So you can also use these functions that should be more or less the same, except in some tricky situations. So let's say that I'm just going to do one example. In which sentences do you find the word night? So you would like all the sentences in the books where you have the word night. And you want to locate, to detect patterns. And if you check the cheat sheet, you will find that, okay, I have grep, and I have grep with value equals true. You provide a search pattern. You provide one string or several strings, and then you enter value equals true, and then you will return all the strings which match your pattern, your search pattern. So if we would try that, here I could write grep. My pattern, I just want to find the word night. So I could write like night like this, but maybe if I want the word and only the word, I could say beginning of the word, end of the word. And then I just want to say, please look in book where I have all my sentences and give me the value, return the sentences. If I do that, you will see that the result of this function is a vector of strings of characters. And if you check all these ones, they will contain the word night. About 2 hours after this occurrence, we heard the ground C, and before night, okay, it's here. I closed not my eyes that night. I have resolved every night. Night. Everywhere in each of these 85 different sentences from the book, you will find the word night. And if you wanted to try to find the night at the end of the sentence, maybe you could try night followed by a dot at the end of a sentence. You try that. What do you see? Night, 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 dot, dot. Here, night. It works. Okay. So you see that there are a number of questions. And all these questions, basically, they are close to what I have shown you during the last hour with the PowerPoint, except that this time you can really try it with book and get the answers. So you can experiment, and when you get the result, you can see if the result is what you want. And that's how you can learn how to practice with regular expression. Does that make sense before I answer JC's question? I have all the answers for this. This is uploaded already, but then it's interesting that you experiment by yourself, and then I provide the answers. Jesse, when to use the round and square brackets? Okay, the square brackets, you use them when you want to say something among a number of characters, a number of options, like A, B, C, A or B or C. And then if you use the hat, anything but these characters here. That's only to search, like to give a number of options. If you use the round brackets, this is to create like groups of things, like this or this. So it's just to group some elements in your search patterns so that there is no ambiguity. Like A or B. Or maybe you want to say like AB or AC. Okay, AB or AC. If you write actually A or B, if you write something like this, or C, or D, okay, A or B or C or D, what you could say is that is exactly the same thing as A, B, C, D. But if you want to look for things like which are more complex, like A, B, A, C, or yet something else, then you cannot use the square brackets. Square brackets to give a list of permitted characters or a list of characters you don't want. So end of string of characters, Longin, if it's the end of the string of characters, what you need to use at the end is the dollar. Okay, that's what is written here. This is the end of a string of characters. If you want the end of a sentence, then you need to explain with the regular expressions how you detect the end of a sentence, which is what I wrote earlier in the chat. What was somewhere like, where did I write that? Okay, like this thing here, that you would look for something like the end of a sentence in quite many languages. Does that make sense? Are you with me before are you okay with that? I explain because you don't provide me with much input. So I just like kind of do it on my own. It's fine on my side. So it's up to you. But then you have all these questions. I advise you try to do them. And then you may check the corrections. That's what you can do. Okay. Any other question? Any other thing you want to ask about these regular expressions? Okay, if no question. So everything is on the Google Drive. What we can do now is just have a 5-minute break. And then I'll tell you more about the standard approaches in text mining. Does that sound like a plan? Are we good with that? Is it okay?
Sounds fair enough.
Okay. All right. But if you really want to learn, don't let it rest, okay? You need to practice. If you practice a little bit, I'm sure you will be able to do it, okay? Of course, if you do numerical stuff all the time, maybe you don't need that. But then it's just about text mining more generally. If you try, the more you tried, then it will sink in. You will feel more and more confident. And there are many tutorials online as well. Okay, so just try by yourself. So I will upload the corrections for this tomorrow or the day after tomorrow, so that you will have them if you want to check everything, which is my recommendation. All right. So let me take a short break so I can drink, go to toilet, and then I will tell you more about the standard approaches to text mining. See you in a few minutes. All right, I am back. I hope you are here as well. And yes, that's a very good question. How and where this regex, regular expression stuff applies in real life. All right, let me give you a few examples. Okay, maybe actually, let me see if I can share something with you. I will show you something. Let me find it and I will share it with you. Script. Okay, I have something I can share with you. Okay. I think you should be able to see my screen once again, and then you can see some R code, okay? And so I think I've told you, yeah, I've told you, I'm sure I've told you, I have a research project where I analyze the French newspapers when they write articles about Rwanda and the Rwandan genocide, okay? So that's a research project. And for that, I have downloaded thousands of articles from one of the online databases I've mentioned, Factiva. But when I download everything, I found that I need to clean stuff. I need to replace a number of elements. I need to do a few things, okay? So this is when I apply regular expressions, at least one application, let's say in real life. You want to deal with text. First, you need to clean things. So let me give you some of the transformations I apply to all the sentences or all my news articles to make things cleaner for the later stage. For instance, if you speak French and if you write French, you know that in French we have this, right? We can have this, like a few words. I found that when I was applying UDPipe and morphosyntactic parsing, UDPipe didn't like at all this the O and E attached together in a single character. It can process the words, but he wants to have O, E as separate characters. So what I need to do before I start the morphosyntactic parsing of everything, I need to turn all these ones into these ones. I found that sometimes they are weird characters as well. I found that I have this pattern in some articles. Weird stuff. And actually, it means OEU. So I replaced this as well. I found that sometimes instead of renseignement in French, I just have RE and S and then a dot. So I replace this. And then I can find that editions can be written with E, A, uppercase, lowercase, stuff like that. I will replace that. There are some errors, like sometimes there are some misspelling. I found that sometimes pièce is written pièce like this. So I changed that. I found a number of things. So I do this to clean everything, to turn everything into how it should be. Sometimes there are spaces before or after an apostrophe. Sometimes there is a space missing after two dots. Sometimes before, sometimes this, sometimes that. So I correct everything, although it does not look exactly, I don't use directly the grep or things like that. It's a little bit more sophisticated, but you see, I use it to correct some typos I could detect, some abbreviations, and yet a number of other things. So that's one case where you can use these regex. Now, if you have cleaner text, you can also use it to detect a number of things. For instance, maybe you've heard that from time to time, newspapers, they work together to analyze large sets of documents coming, for instance, from fiscal paradises or from banks. So I was checking this today. Maybe if you check, you will hear about that. Blah, 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 blah. It's on my phone. All right. You cannot read because of this. Well, Le Monde today, which is the one of the best known French papers, they tell us about some dirty money that was hidden by a Swiss bank, the Crédit Suisse. And basically someone gave them hundreds of thousands of documents from the Crédit Suisse, documents which should of course remain private and secret, but someone took them away and shared them with the media because he or she thinks that's not okay. How do you analyze so many things? Maybe you can use regular expressions to help you to process things a bit faster or to discover interesting things. Maybe you can use regular expressions to locate all the phone numbers or all the IP addresses or all the amounts of money. So you can write different expressions for that. Or you may look for specific countries. So you look for everywhere in documents where you have the word, I don't know, India. Why not? Or yet something else. Or you may want to find India or Indian or yet something else. So you can use regular expressions or Delhi or the name of some government persons in India. So you can use regular expressions to locate a number of pieces of information in your documents. I would say these are the two main applications, but I'm sure you could find yet others. Does that make sense, Agnes?
Yes, Professor. Now
Okay.
I got it.
Okay, very good then. So, yeah, that's how you may use these things basically. Do you have any other question before I move to this this one, or are we good? So you need to practice more. I just demonstrated a few things. Sorry, it's not how I want you to see it. Okay. Any other question? Is it okay? Okay. So let me tell you, for the remaining time today, let me tell you more about the kind of things you can do in text analytics. We have seen regular expressions. That's one thing. It's not the most advanced thing, but it can be useful to clean documents, stuff like that. What else can we do? How can we push our analysis further? So that's the topic of this lecture. And here I'm not going to tell you about deep learning. I'm going to tell you about the more classical approaches. That means the approaches without deep learning. So these techniques, they are commonly used. So what are they? Before the revolution of deep learning, how do you need to transform or prepare your data in order to apply these techniques? And where are you as a human being? Where are you in the process? Or you could ask, how much is left to human interpretation? How far can the machine go? And you will see that actually it cannot go so far. You still need to interpret the outputs of the different algorithms. So this is what I can share with you in this lecture. So what do you want to learn from your data? That's the primary question when it comes to choosing which are the analyses you want to consider. Maybe you have a data set of online comments for products that you can buy on the platform, like Amazon or like Taobao in China. And maybe you have specific ones in Rwanda or in other countries in Africa or elsewhere. So maybe you want to know whether customers, they like or dislike a product. Can you automatically extract that from their online written comments? Or maybe you have a set of news articles focusing on human rights, waste recycling, COVID-19, corruption in Southeast Asian countries, digital innovations in African countries, whatever, okay? But you want to be able to extract the topics which are addressed in these news articles. Or if you are more of a linguist, you could also look for different syntactic structures. How do they occur in a large corpus of natural language? That's something rather different, but why not? You could also do that. So here, what we could say is that maybe we want to distinguish between the surface or the form of the documents and their content. Another way to put it is to say there is what is written and how it is written. So if you focus on how it is written, you focus on the surface, you focus on the style. So that's what we call stylometrics, and this is a specific area. In this lecture, we are going to focus more on content. So what is written rather than how it is written. We have discussed this already. You may choose a purely quantitative standpoint, okay? Especially if you don't know well the documents that you have in your data set. Maybe you just want to use these automatic tools, these text mining tools, and try to understand what they say. But maybe you know actually more than that. You know actually the documents, maybe you have read some of them and everything. And then you want to have your computational quantitative approach, but then you may also want to have a more qualitative, a more human approach to the document. Both options are interesting, and you can compare these approaches. I mean, it depends what you want to do, what you know already, but you have quantitative, you have more qualitative, you can compare, you can have a more complementary approach. There are a number of options here, basically. This actually we also have discussed already. Someone asked me the question last week. What is the adequate size for a document? How should we choose our documents when we have a data set, when we have large amounts of text? It depends. There are sometimes more intuitive choices. Let's say that you have 30,000 news articles on Rwanda, then it makes sense to have one news article, maybe one document. But maybe you could also cut your news articles into smaller sections and have more than one document per news article. Maybe that would also make sense. If you analyze books, maybe you want to say one book, one document. Or if you analyze a single book only, maybe one chapter or even one paragraph equals one document. All these options make sense. So once again, articles, book chapters, you may cut them into subunits like paragraphs. Maybe that raises the question, how large should documents be? If your documents are too small, too short, maybe that's not so good. So having one sentence, one document, I don't think you will learn much from that. So at the same time, you may also have finer grained analysis, but you need to consider the trade-off here. If it's too short, it's not good. If it's too large, maybe not so good from time to time. So you need to find what is best. Let's say you have news articles and you want to understand how they are structured. Then you are not going to consider one news article equals one document. You are going to break it into smaller components. So there is no obvious answer. It will have an impact on later analysis for sure, but it depends on your goal and whether you actually need very fine-grained analysis or not. It depends. So to illustrate the various techniques in this lecture, I'm going to take some examples, and they come from two sets of documents. Frankenstein, the same novel actually I used, or you can try to play with to try further with regular expressions. And here, one document means one chapter of the book. And then I have something else. I have a database of plot summaries of Hong Kong movies. So in Hong Kong, they used to make quite a lot of movies, a little bit less today, but still. And then I have summaries, like paragraphs, which summarize the movies. One movie, one paragraph. So one document, one paragraph, one summary, and this comes from Wikipedia actually. And there is a data set with a lot of plot summaries for movies from Hong Kong, from the US, from India, for many, many countries. And actually I gave you the link, is this kaggle.com Wikimedia movie plots. You could find all these summaries there. And when we look at Frankenstein, the data set is ordered in the sense that the chapters of the story make sense, right? They come one after the other. So if we want to study the topics or the sentiments, we can study them as the story progresses, as it unfolds, as we learn more about it. So I can take examples from these two data sets. And we could yet use something else, of course. But that's what I can share with you today and tomorrow. So just to give you an example of a movie plot summary, this is a movie from Hong Kong. It's like a kung fu movie, very likely. And you can see Lan Tinlung, master of the Liangyi castle, calls upon all upright swordsmen to help wipe out the notorious lunar sect. But he is soon fatally wounded by the sect's leader, nicknamed King Hell. Lan's daughter, Lan Feng, sets out to find a precious herb capable of curing her dying father. And then you have the story, blah, 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 blah. In the end, King Hell is killed in the battle finally. So that's just, in a few sentences, the story of the movie, and have a few hundreds like this. So at the end of this lecture, what I wish you were able to do was to describe various approaches in text mining, studying collocations, topic modeling, sentiment analysis, word embedding, apply a number of analyses to a corpus of documents, and also maybe at a broader level, reflect on the nature of the meaning of words and linguistic expressions. How do we access the meaning of a word? Where does it come from to some extent? And the meaning of whole sentences. So when you study some of these tools, like topic modeling, for instance, it kind of makes you think of how do computers deal with the meanings of words. That's the point. So first, I will tell you about how to discard and preserve information in text for further analysis. I'll come back to lemmatization, as I told you I would in last week. I'll tell you about word clouds. I'm sure you know word clouds already, but also co-occurrences and collocations. Then I'll tell you about sentiment analysis and topic modeling. And then I'll end with something more recent, which is word embedding, which is quite interesting. So these are the different sections of this lecture. And the take-home messages, usually the documents that you start with, you simplify them quite a lot in terms of linguistic structure. You apply lemmatization, which I have already defined, at word level, and at sentence level also you have what we call the bag of word approach, and you will see how it works. But basically you discard a lot of information, and that works well enough. So that's what we do in classical text mining before deep learning. And basically there is a trade-off here. You need to find the right balance to have enough semantic information, to have enough semantic signal that you can extract and interpret. You want to discard linguistic information so that things are not too complex. Because if you have complex sentences, complex textual representations, it's hard to deal with them, to put it very simply. But at the same time, you want to preserve enough linguistic information so that you can meet your objectives. For instance, you want to classify or you want to cluster documents, you need to have enough information for that. So if you discard too much, then it won't work so well. And final message is that text mining, usually it's about large scale perspectives. Okay? You look at things from a a bird viewpoint. So for instance, you have tasks at the level of whole documents like classification, summarization, sentiment extraction. You are not looking at individual sentences in detail. You are not doing what linguists are used to do. You are adopting a broader perspective. So that's something quite important, I would say, about text mining. If you have only one news article, there is no point doing text mining. It's easier to read it by yourself, and that would be faster and more effective, actually. But if you have thousands and thousands or tens of thousands of documents, then maybe text mining is for you. Does this introduction make sense? Do you have any question? Or are we good? And I can just continue. Are we okay? Good. Okay, clear enough. So first part, discarding and preserving information in text for further analysis. I just told you there is some sort of trade-off here, and I want to explain more about that. So you have your data, you have collected them properly, you have cleaned them, possibly using regular expressions, and now it is time to analyze them. One option is to apply very sophisticated statistical methods directly, and that's especially deep learning. Then you just provide like a big neural network, you provide the sentences and just like this without doing anything. But another option, which is more which is older, which dates from before deep learning, is to first transform the content of the documents, especially with the tools of NLP. And we have actually covered that before. Part of speech tagging, shallow syntactic parsing, these kinds of operations. That's something we may try to do first before moving forward. Two options. Today, I'm focusing on the second one. So if you have your sentences, you may have something like this. The little cats fell asleep. That's one sentence. So when you have a sentence like this, I've told you that already, we have inflected forms. We have cats, plural, fell, past tense of to fall. And working with these inflected forms, that may be good sometimes, especially with deep learning, but that may not all necessarily be the best approach. What I mean by that is that transforming the words first, that may help to get closer to what they mean. You will lose some information in the process, but that may actually be not a bad thing at all. Some additional operations degrade the information you have in a sentence, but despite the fact that they degrade information, they are widely used. People don't think it's a problem. It can actually be some sort of an advantage. And once again, I'm going to explain that. I've told you about lemmatization. I'll just tell you about something else that is quite similar, but a bit different at the same time. People sometimes they use this rather instead. This is what we call stemming. So it's a common operation. And when you stem something, you reduce an inflected form to its stem, hence the name stemming, its base, its root. And the stem is the part of a word which is responsible for its lexical meaning. So some simple cases, flying is fly plus ing, the stem is fly. Cats, the same, the stem is cat. You drop the S for the plural. Snowed, you keep snow. This is very straightforward and it looks very much like lemmatization. But there are some cases which are more challenging. So we need to pay attention to them so we understand the difference between stemming and lemmatizing. So there are a number of issues which can arise when you reduce things, and it depends on the language you are working with. Hebrew is more challenging than Russian, for instance, which is itself more challenging than English. So things are more difficult if the stem is modified by a number of affixes like prefixes, suffixes, small parts that you add before or after the stem, or if the stem cannot appear alone, like you could have cats but not cat. In some languages, it's a bit like this. So then you need to pay attention what should you do. So there are different options, and you should decide what you want to keep as a stem. In some approaches, stem actually, they are not words which exist. Like if you look for the stem of browse and browsing in English, then the stem that, like a stemmer, the program which does stemming returns, is browse. That does not exist in English dictionaries. So stems are okay like this. People can still think it's okay, but it's not very meaningful if you are, let's say, a linguist, okay? It's acceptable in most cases if the related words, they map to the same stem. Okay, browse and browsing are related. If you want the stem to be browse, ending with S, okay, why not, right? That may still be okay. Many people use this. So we have stemmers. They are programs which perform stemming. And they can make mistake. They can overstem or they can understem. Overstemming is when you relate words which should not be related. So let's say your stemmers, it says universal or university or universe, and then the stem it will propose will be the same for the three words, universe. But actually universe and universal and university, they are not, especially university, they are not that tightly connected. So that would be overstemming. And then let's say that you have alumnus and alumni, and then understemming, you get two different stems for these two different words. But actually that's not right? Because one form is the singular and the other one is the plural. So if a stemmer fails to offer the same stem for both of these words, then it's not okay. That's what we call understemming. So how do you achieve stemming? Well, there are a number of very well-known techniques. You may have some sort of dictionary, like a lookup table. And you have in one column, you have all the, like many inflected forms. And then on the right, in the second column, you have all the corresponding stems. And you look in the table to find the stem for a given inflected form. That's nice, but there are many cases where you can have ambiguities. You may also have rule-based approaches. So how you can, like you define rules to create stems. For instance, suffix stripping. So you have a rule like, okay, if I have a word ending with ed, then you should remove the ed. So that if you have something like talked, then the stem will be talk. And that seems pretty nice. The problem if you have only this rule is if you have the first name Ted, then the stem will be T, which is totally meaningless. So if you want rules, then you need to have rules for all the tricky cases. And then you have more sophisticated algorithms, supervised decision trees, whatever. That's what we call stemming. And it may not be very linguistic as an approach, but that's what many people rely on. If you ask me, I don't like it much because I don't like to have stems which are not actual words. I find these stems are harder to read. So I don't like it so much. But anyway, many people use stemming, and you have tools in R how to perform stemming. What I prefer personally, and what I've told you about already, is lemmatization. Actually, it's a kind of form of stemming, but it focuses on the lemma, the inflectional root. That means that when you do lemmatization, the result is always a word which exists in a dictionary. The lemma is the canonical, the dictionary form of the words. So if you have run, runs, run, running, then the lemma is the infinitive form to run. If you have chatters, then the lemma could be chatter instead of chat, which is a bit further away, although it's related. This one is the lexical root, not the inflectional root. If you take a sentence like the children gave an apple to Mary, if you extract all the lemmas, the sentence will become the child, singular, give for gave, for an apple to Mary. So here I have lemmatized all the words, all the inflected forms in the sentence. How do you perform lemmatization? Well, you need to do what we have explained already, what we have introduced before. It's a morphosyntactic analysis, where you try to find the syntactic roles of the elements of a sentence. And compared to lookup tables and stemming and stuff like that, it would be much better to deal with ambiguities. Sentences like, I saw a saw. This is ambiguous. With stemming might not be so easy. But with lemmatization, if the morphosyntactic analysis is good, you will solve the problem, the ambiguity. And because you perform a morphosyntactic analysis, you can say that the approach overall is more linguistic. So I prefer this. That's my personal taste. Many people, they are totally fine with more general stemming. I like lemmatization, but I like it also because I have all these nice tools like UDPipe functions to do it, to perform the morphosyntactic analysis. I have my table, and in my table for each inflected form, I have the lemma, I have other pieces of information, I have the part of speech, whether it's a noun or a proper names or a verb or an adverb. I like this, but not everybody is like this. So that's the most important part, I would say, of this section. Why do we need to bother? Why do we need to stem or lemmatize? The answer is that stemming allows to compare documents beyond like the morphosyntactic specificities of the sentences. Let's take two examples. Let's take one example with two different sentences. The child plays with the cats. There is one child, there are several cats. Or the second sentence, the children play with the cat. Here, as human beings, we very, very automatically relate child and children. We also relate cats and cats. That's very, very obvious. And we know that plays and play is the same verb, but in the first sentence, there is the agreement, third person singular. The point here is that a computer does not know that. For a computer, cats is a string of characters with 4 letters. Cat is another string of characters with 3 letters. It doesn't know that there is some connection between the two at first. It doesn't know that plays and play are related. It doesn't know that children is the plural of child. So if you just provide these two sentences without any transformation, the computer would judge them as likely very different. Okay, they have three words which are shared, but child versus children, place versus play, cats versus cat. If these three pairs are considered as made of different elements, then these sentences, they are quite, I mean, they are not comparable. They are distant from each other. Now, if you lemmatize both sentences, you will get, in the first case, the child play with the cat. In the second case, the child play with the cat. And then the two sentences, they are now very close, or actually identical. Because now the strings of characters for the different lemmas, they are the same. So the computer will agree that these two sentences, they are very, very close at the semantic level, because it pays attention to lemmas. So you have what you could call conflation. That means if two words, they have the same stem, then basically you consider they mean the same thing. It's not true, of course, but you may accept something like this just to make things simpler. Of course, in the best possible world, you would use both stems or lemmas and some morphosyntactic information. You would use the fact that children is the plural of child. But actually, very often, you discard this kind of information. You discard this knowledge, and you focus only on the lemmas. So, what do you think is better? If you have the child plays with the cats, or the children play with the cat? If you look at things from a broad perspective, from a high elevated vantage point, what do you think is better? Do you think it is better to consider that these two sentences are very different, or to consider that they are very close? What would you say? Very close or very different? Right? In both cases, it's about children, it's about cats, and it's about playing. So it seems better to consider them as very close. And that's why it's important to perform stemming or lemmatization, because then these sentences, they would be considered as pretty similar or exactly similar. And that's what matters. That will give you more interesting results when you look at a large number of documents. Of course, that means that if I have 30,000 news articles on Rwanda, I will need to do a morphosyntactic analysis for all the sentences of all these documents. It will take a bit of time, but actually not that long, and you need to do it only once. And then you can move further. Sometimes lemmatization or stemming will fail. The results won't be perfect. Maybe it works like 95 or 98% of the time. If you have too many errors, that's not so good. But if the errors are not so frequent, it won't be perfect, but you will have enough signal and not too much noise. You will have a good enough signal to noise ratio. And that's what you want. You won't be able to extract everything perfectly, but if it's good enough, then maybe that's okay. Because to correct absolutely everything is just too time consuming. So you don't need to understand all the sentences so well in terms of morphology and syntax. If it's good enough, you will find that you can extract what you want to find in your documents, like the topics or the sentiments. So that's one first important thing. Give me 1 second. Okay. There is something else people will do very, very often. They will drop the closed class words. That's the other name for grammatical words. The prepositions, the articles, the what else? You will drop the to, before, after. All these closed class words, you will discard them, which means what will remain will be the open class words, the nouns, the verbs, the adjectives, the adverbs. You will work only with them. But that's okay, because they are the words which carry information. They are the primary content carriers. So of course, you lose something in the process, because closed class words, they carry important information about thematic roles. For instance, the child plays with the cats. You lemmatize, the child play with the cat, and then you remove all the closed class words like the, with, the, and you have child, play, cat. Is the child playing with the cat? Is it the cat playing with the child? That may become ambiguous. Or John gives Mary Ted's book. If you drop everything, you will have Mary, John, and Ted, and you don't know who is giving what to who. So you will lose something. But still, if you have child, play, and cat, you will have what the sentence is about. It's about child or children playing or being played by cat or cats. Is it possible to use both lemmatization or stemming, or should we choose? I'd say, you choose, lemmatization in a way is a specific form of stemming, which involves more morphosyntactic and linguistic analysis. So you choose one of them. People do stemming most of the time. And usually the form of stemming they use is not exactly lemmatization, something that is not as precise linguistically speaking. So you choose a method to reduce your words, your inflected forms. So yeah, that's what I would say. Once again, which kind of stemming you want exactly? Do you want lemmatization or something not as strict? This is up to you, but you should choose one method. Okay, Emmanuel? All right. Sure, no problem. So the themes will be preserved, but although who, what precisely, the agent, the patient, the location, this will be lost, but maybe still okay. You may actually go even further than that. There are some very frequent words which may also be discarded. Words which are not very informative, even if they are open class words, like be, go, again, these kind of words. They are very frequent and they won't tell you much about what documents like specifically contain. Be can be used for like, I am doing this, he is doing that. Be here is a grammatical device. You don't really need it maybe. So it's more about the language itself than about the meaning of what is being written. So sometimes, if you go online and you type in Google, like a stop words list English, you will find a number of different lists. And these lists, they contain stop words, which mean words that you want to discard because they are not very informative. Sometimes the lists of stop words, they contain inflected forms. Sometimes they may contain only stems or lemmas. It depends. And so you may use them even if no stemming is performed. That may be okay. So this is an example. and you know where to find it. You have the address at the bottom, in the bottom right corner of the slide. This is a possible list of English stop words. About, above, after, again, against, all, and. So you see it's inflected forms here, and, any, are, aren't, as, at, be, because. So you have some closed class words, but you also have some verbs, some stuff, some personal, a few things that are lemmas, sorry. So you can drop all of this, and there should still be enough content in your documents. All right. We can go even further. That's what we call the bag of words approach, or BOW approach, bag of words. The idea is that the words, they become like if they are in a bag, completely disordered in a way. So the idea, the principle of the bag of words approach is to discard word order and sentences and just consider documents as an ordered collection of words. So that one word comes after another in a sentence, this doesn't matter any longer. So it's very crude, linguistically speaking. It's just like if words were in the bag. What you may do, however, is for each word in a document, keep how many times it appears, what we could call the multiplicity. But that's it. You destroy the order of the sentences. So if you have something like the children gave Mary an apple, if you destroy the order here, you would have an apple, children gave Mary the, and there is no order here. I just follow the alphabetic order, but it's not meaningful. And if you have the sentence, Mary gave the children an apple, the bag of words, the result as a bag of words will be the same as as the previous sentence. Because here the difference between the two sentences and their difference in meaning is just depends totally on the order of these words. So if you destroy the order, these two sentences, they can no longer be distinguished. That's what we call bag of words. And then you can combine the bag of word approach with lemmatization or stemming and dropping a number of words which are not very informative. So if you have a sentence with the children are happy to play with the cats, if you apply all these transformations, in the end, you have 4 words and only 4 words without any order: child, happy, play, and cat. You don't know. You know that there are children and cat and play and stuff. Who is happy? The child or the children, the cat or the cats? You don't know. You just know that there is happiness involved. What do I mean by order? It's just one word coming after another in the sentence. So if I say hello, just this sentence, I have a word order, right? I comes first, then say comes second, hello comes third. That's the order of the words in the sentence. I can destroy this order, and then I just have 3 words, but no specific order. That's what I imply when I use like this, this bracket and elements separated by commas. No order. So a lot is lost in the process, very, very obviously. However, these limited, very limited representations, they still give pretty good results in different tasks. If you want to assess the text, the similarity between different texts, a bag of word approach with lemmatization and dropping of non-informative words, that will give good result. All the tasks which can be performed well enough without focusing on individual sentences. If you want to have a global perspective and you don't require a local perspective, then this very drastic approach that would be fine. You can order them alphabetically. I mean, when you want to write the words, you need to choose an order anyway because you write them. But what I mean is that for the computer, there will be no order. If you order them alphabetically, what do you gain by doing that? If you reorder according to alphabetic order, maybe that can be useful if you want to compare different sentences. So you just assume that both sides are alphabetically sorted, and that may help you in doing a number of procedures. But just broadly speaking, there is not much point using the alphabetic order, because this alphabetic order, it doesn't have any connection with the way we order words in sentences to create meaning. Alphabetic order is just the order of the letters in the alphabet, right? There is no meaning, it doesn't explain why apple is a fruit like this or like that, or why, I don't know, happy is a joyful, is a positive feeling or anything. So you can do it technically in your computer, but the alphabetic order doesn't bring much, apart from like building writing algorithms, but it's not about meaning. Does that make sense, Emmanuel? Your words will always be sorted. Like if you put them in a table, there will always be a first row and a second row and a third row. So the words will be ordered because a computer can only play with ordered structures. But this order won't be used to extract meaning. It will essentially be meaningless. But a computer actually always orders things, because if you have a vector, you always have a first and the last element. Yes, if you destroy the order, you lose the meaning of the sentence. You lose the precise meaning of the sentence, but you don't lose completely the meaning. Paul gives Mary a book. Mary gives Paul a book. If you destroy the order of the sentence, if you have a bag of word approach, you don't know if Paul gives the book to Mary or if Mary gives the book to Paul. You don't know anymore. So you lose partly the meaning of the sentence, but you still know that there are two people involved, Paul and Mary, and that there is a giving action, and that it involves very likely a book. So you don't lose everything. You lose part of the information. But you could argue that you still preserve quite a number of interesting elements. Does that make sense? Is it okay, Emmanuel? You lose something, but at the same time, simpler representations are easier to process, are faster to process. If you get good results with them, why not simplify stuff? That's good. That's useful. When you do the bag of words approach, something that is quite useful and is very common is what we call a document term matrix. And there is just the opposite, which is a term document matrix. That's the same thing, except that in one case, the rows are the documents and the columns are the words or lemmas. And in the other case, the documents would be the columns and the words or the lemmas would be the rows. The same stuff. It's just the transposition of the matrix. So what is a document term matrix? GTM. It summarizes the occurrences of terms, the stems or the lemmas, if you chose that, or the inflected forms directly in a set of documents. So let's say that you have 3 documents, 3 sentences, okay? 1 document, 1 sentence, very simple. John offers an apple to Mary. Mary gives a pear and an apple to Peter, and John gives a bone to the dog. We do bag of word, we do lemmatization, and we drop words like and to and stuff like that. The first sentence, the first document becomes apple, John, Mary, offer. The second document, apple, give, Mary, pear, Peter. The third document, bone, dog, give, and John. So what we can do is we look at all the different words we have. We have apple, bone, dog, give, John, Mary, offer, pear, and Peter. These are the words for the 3 documents. And then on each line, you have a document, and you will write the number of times a word appears in the document. Let's say document number 1. Apple does appear, it appears once. So we write 1, that's here. In the first document, we don't have the word bone, so that's 0. We have the word dog, no, so that's 0. Give, we don't have it. We have offer, actually, 1. John and Mary, we have them, so that's why we have 1 and 1. Pear and Peter, we don't have them, so that's 0 and 0. Then we do the same with document 2. Then we do the same with document 3. And what we have here, this table, this matrix, that's document term matrix. Do you see how it works? It's really not meant to be difficult, right? Do you see how I construct my matrix? I just get all the different possible words for the columns, all my documents for the different rows, and then I enter the counts, sorry. Of course, here I have 3 documents and I have 3 short sentences. So my matrix is really not a large one. Now, if I have 30,000 documents, and let's say that I keep the 2,000 or the 20,000 most frequent words, I discard the infrequent words. If I give this, I will have a matrix with 30,000 rows and 20,000 columns. That's a huge matrix. In some sentences, I will have a word appearing in some documents, sorry, a word will appear several times. So I won't have only 1 and zeros. I will have like 2 or 5 and 2 and 1 and zeros, etc., etc. And my matrix would be very, very big. That's usually a problem to store the matrix in the memory of the computer. That's why we have special ways to represent matrices which are sparse. Because in this big matrix, there will be many zeros, very likely. And then we can encode this in a more effective way. That's what we do in R, for instance. But the idea is here. We create a matrix which represents how often the different words appear in the different documents. And here you can start to see what is going on. If you have 2 documents which are very close in terms of their numbers, which go in pairs. If the numbers are very close, what does that mean? That means that at the semantic level, our documents should be quite similar. And that's the beginning of further investigations and especially topic modeling. So the document term matrix is useful to understand the content of the different documents and how they can be related close to each other. That's the point. So as I've just told you, the DTM document term matrix is a starting point for some further analysis, especially topic modeling. A topic modeling algorithm will take as input a document term matrix very commonly. We have seen different steps to simplify the content of the documents in order to grasp the lexical and the semantic content. For some approaches like topic modeling, you have to do that. For some fancy approaches with deep learning, you don't need to do that. Sentiment analysis, for instance, it will work better if you keep the complete sentences. Why is that? Well, I can show you right now. I am happy. I am very happy. I am not happy. I am really not happy. I am not that happy. If I use bag of words and I drop the closed class word and everything, blah, 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 what will I have in the end? I will have I happy. I will have only these two words. Okay, so happy is positive feeling, positive sentiment. Okay, so should I conclude that all my sentences are about something positive? Of course not, right? Because not means the opposite. I'm not happy. The sentiment is negative, actually. It's the opposite. Plus, if I am happy, maybe you could say the sentiment is positive, let's say +1. I'm very happy. Then maybe it could be +2. I am incredibly happy. Maybe the score would be +3. I am really, really not happy. Maybe you want it to be -2. So you see here that if you reduce the sentences too much, now here you are losing valid information for the specific task that is sentiment analysis. Will be fine for topic modeling. It won't be fine for sentiment analysis because sentiment analysis works as a more local scale. You want to keep more information in the sentence to better predict the sentiment. Today, you can have thousands or hundreds of thousands of documents and hundreds of thousands of terms. If you have a strong computer today, that will still be not an issue. It may take some time, but eventually it should work, especially if you have enough memory in your computer. Why will not have am when we use both? There are two different things. Sorry, maybe I've confused you a little bit. The bag of words just mean you destroy the order. Okay, so if you have I am happy, you will just destroy the order and then am is still here. But usually we do the bag of word approach on top of lemmatizing or stemming everything and dropping the closed class words. We tend to combine these different operations. So in that case, am, the lemma is the verb to be, and be is very often discarded because be is not very informative to be. And then you only have I and happy. Does that make sense? All right. So you see, we we try to discard and we try to preserve the right amount of information so that then we can apply our different algorithms. Topic modeling, you can discard quite a lot. Actually, it will be better this way. And you need to lemmatize also, that will really help. But if you do sentiment analysis, then you need to preserve way more. Otherwise, you cannot really assign a sentiment to a given sentence. Is that clear enough? Is it okay for everybody? Or do some of you have questions they would like to ask? Please let me know. Clear for Longin? Okay. Sorry, I do just a small thing while you are checking. All right. Okay. Clear for so I hope it's clear for the others who will hardly ever say anything. Okay. So I will do the second part, and then that will be okay for today, and then we can continue tomorrow, and I can show you a bit more about that. So we clean our stuff, we stem or we lemmatize, etc., etc. Then what can we do? We can start to do a few simple operations. So I'm going to tell you briefly about word clouds, co-occurrences, and collocations, and I can take some examples. Word clouds, I'm sure you have seen them before. They are very popular to represent the overall content of a set of documents. It's a very global description, with a global measure. So it's definitely not at sentence level. The words or the terms like the lemmas, you are going to display them on the screen with a font size very often, which is related to how frequently they appear in the corpus. And when I say related to, the font size may be proportional to how common they are, but sometimes it's not proportional because it may give like very, very large words and very, very small words. So you may have something which is not linear. It may not be strictly proportional. And then you may have various fancy options. You may have different colors. You may choose different shapes. You may do this, you may do that to create your word clouds. You may filter some categories of terms. So for instance, in your set of documents, you may focus on words of verbs, adverbs, adjectives, and nouns. Or you may focus only on proper names or only on verbs. That's okay, you can do that. And choosing different options may provide you with different perspectives on your data. So that's an example. These are the most frequent lemmas for proper names, nouns, verbs, and adjectives in the novel Frankenstein. On the left side, actually, you see like an Excel table, like a table. You see the words, that's the key, the lemmas, and you see their frequency. Like man appears, the lemma man appears 176 times. Father appears 134 times. Day appears 130 times, and so on and so on. And they are ranked by decreasing frequency. That's one way to represent things. That's a table. It's totally fine. But when you try to communicate and convince people, maybe you will find that a word cloud is more attractive. And that's what you can see on the right. You see that the words that have the higher frequencies, like man, father, day, friend, life, they appear bigger in the word cloud. And then the smaller words, they are less frequent. So just by looking at that, you start to learn a little bit about the novel, the story of Frankenstein, even if you haven't read it. Father, friend, feeling, man, life, love. That's a story with human beings and their relationships. Okay, many novels are like that, but maybe not all novels. And if you read also like, okay, horror, murder, misery, destroy. What else do you have? Creature, despair, spirit, fear. You see these words in the cloud, right? So this novel is unlikely to be a comedy, given these words. And then you see the names of the main characters: Elizabeth, Felix, Clerval, and yet a few others. You see also happy, discover, power, wish. It's not only negative, right? So it may not be a pure horror thing. Happiness, you see also happiness. Give, return, etc., etc. So this is very broad, very high vantage point, but it tells us about the story. These are the most frequent lemmas, same. Proper names, nouns, verbs, and adjectives, but this time in plot summaries of Hong Kong movies. Kill, policy, police, man, father, brother, family, gang, wife, thug, money, lead, arrest, attack, gun, order, save, leader, master, shoot, cop, etc., etc. You don't know exactly what you will find in the stories, but I mean, it's pretty easy to get the idea that these movies in Hong Kong, and that's the case, of course, they are often about family members and friends, police, gangs, triads, the local gangs that we call triads here in Hong Kong and in China, martial arts, and overall, they are quite violent. You can get that just by reading this, by looking at this cloud. And this cloud is quite different from the one for Frankenstein. It's very broad, but let's say it's a starting point. And you have to start somewhere. So why not start with something like this? The colors here, they are not meaningful, but we could use one color for the verbs, one color for the proper noun names, one color from the nouns, etc., etc. That would also be interesting. Maybe we would see something additional. So it's nice, it's fancy. I wouldn't say it's game-changing. If you are a data scientist, you can do very well with the table, with the word list. It's not as beautiful, but if you are like if you are at ease with numbers, that's fine. It's if you want to communicate with a more general audience that a word cloud may be nicer in a way. But this is only about the frequencies of different terms. It's not very deep in terms of analysis. So, okay, it's good to have a word cloud, but definitely you cannot stop there and say, okay, that's enough. No, right? You need to move further. So first you can do it, but then you need to analyze things more qualitatively, You can try to analyze the pattern of distribution of terms and terms frequencies. You can try to build connections between the words. That's a small work you can do. Like I told you, okay, if you look at this word cloud, okay, you see daughter, friend, man, wife, master. Okay, there are relationships between people. That's one group. Then you have gun, attack, murder, thug, etc., gang. That's about gangs and triad and stuff like that. And then you might find yet another category. So you can build connections from from the word cloud. It's good. It's a first step, but actually, why not try to detect connections in a more effective way and automatically? This is when you can look at what we call co-occurrences. For instance, you have your text corpus and you have all your sentences, and you don't do the bag of words approach or anything. You take your sentences and you look at all the possible pairs of terms. One word followed by another one directly. Actually, you may look at inflected forms, you may look at lemmas, you may look at open class lemmas only. Actually, you may drop some elements. But when you have the result, you don't destroy the order and you look at pairs, successive words, all the possible pairs, sorry. So to put it differently, you go one step beyond individual words. And then for each pair of terms, you count the number of times they appear together in the corpus. And here, actually, you may do something else. You may not look only at successive words, but you may say, okay, I want to look at all pairs, but I'm going to allow for 1 or 2 or 3 words between them. That's also possible. And you might vary the maximum distance you want to allow between 2 terms in a pair. And what you are doing here is that you try to find interesting, frequent co-occurrences of terms. It's still something quite global, but now the way you measure things is more local, because you want to look at words as they appear in sentences with the order. So that's a local measure for a global description. So now we are going to inspect pairs of terms rather than only isolated terms. Let's have a look of what we can get with this approach. Just to make sure, okay. Frankenstein told Mary that blah, 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 blah. Frankenstein later gave a book to Mary. Or the sentence, Mary, Frankenstein wants to see you. In the first sentence, you have 1 word between Frankenstein and Mary. In the second sentence, you have 1, 2, 3, 4, 5 words between Frankenstein and Mary. In the third sentence, you have 0 word between Mary and Frankenstein. So you see, if you choose to have 2 words at most between Frankenstein and Mary as a pair of terms, you will pay attention to the first, you will count the first and the third sentences. If you allow up to 5 words in between, then you will account for all these sentences. So you see, varying the maximum distance will have an impact. So what do we get when we do something like this? So I have told you about that. You may consider more than 2 terms and investigate more complex co-occurrences. Okay, I should tell you that. You can also look at triplets, not 2 terms, but 3 terms. That's also possible. Can also be interesting. The idea here is that the co-occurrences, they will reveal something interesting at the semantic level. You will learn about the relationships between the terms, between the words. And what you can do, actually, you can have a table. Do I have a table to show you? No. You could have a table with all the pairs that are the most frequent. But actually, you can do something interesting as well, which is to create a graph, a network of co-occurrences. The vertices, the nodes of the graph, represent the terms, and the edges represent the co-occurrences. And if you have more frequent co-occurrences and less frequent ones, then you can represent everything with thicker or thinner edges. How does that look like? It can look like this. So this is a co-occurrence network for Frankenstein. So you see, you have words, deer, okay, I like deer, and okay, annotate, color. Okay, man here, and deer, and family, and low, and ice. And then you see that there are a number of connections between these words. For instance, you see here that you have like a cluster, right? A small, well, sorry. Then I'm going to clear of it. If you check this, what you see here is that ice often appears with breaking ice. Ice often appears with raft. It appears with sea, and sea with ground, and also ice with mountain, and mountain appears often with snowy. So it tells you something about here, very likely the environment, or at least one of the environments in the novel. That's because there is a part of the story initially with a boat in a very cold sea, like not far maybe from one of the poles, like the North Pole or Greenland or something. Then you see creature, for instance, here. And you see that you have a connection with human, and a connection with noble and with capable. And then a connection with Elizabeth. And it tells you more about this creature and what he or she can do, or he or she is. There are yet other things that you may notice. Here, that's also interesting. You have natural, and it connects with natural philosophy, natural branch, natural science, natural history, modern natural, and modern and philosopher. So this story has to do with science and philosophy. That should be quite obvious given this cluster of elements, this small subgraph within the larger graph. You see here you have horror and despair, and horror and breathless. You have greatest delight, but also danger and attention and pleasure and eagerness. So you see that you can have quite exacerbated feelings and sentiments. You also see like man, and there is young, there is genius, there is wonderful, but there is also miserable and wretch, which is not so far, and excellent. And you see that you have different features for a human being, etc., etc., etc. So you see how we can learn something more about the story with such a network. It's not very difficult to build, but we can use it and learn a little bit more. That's the same kind of network, but this time for the Hong Kong movies, sorry. Okay, we see a few things. Okay, we have Kung and Fu. Not so surprising, right? Kung Fu, very common. Not so far Kung, we have a master and style. And then when we look at father, we have family and wife and man, but also fight and art and student and identity. Tells you a little bit also. Member, leader, gang, triad, all these things are not so far away, and they are connected with cop and boss and police. And police, of course, we have a lot of elements. So you see very obviously with something like this, that police is an important component of these movies. We have officers and van and case and killer and drug and station and money and inspector and team and summit. A lot of stuff about police. These words with no connection, it could be that here we we look at the most frequent pairs, the most frequent connections. So you need to have a cutoff. Either some of these words, they just don't appear close to each other, so there is no connection at all, or maybe they appear together, not far from each other, only once or twice, and it's not enough that you should represent it. Otherwise, in the end, maybe like kind of everything is connected with everything. So you focus on the strongest connections. If you check, you have drug trade, drug lord, drug chung, not sure chung is a name, drug and police, drug and thug. Drug is often an element in these movies because the triads often they are involved into drug trafficking. Okay? And then you see a few things, birthday party, construction and site. It's, I mean, you learn more stuff about the kind of documents. And here that means you learn a little bit more than with the word cloud about the movies, the stories of these movies. You can do something more, which is going from co-occurrences to co-locations. They are quite similar, but there is a difference. The point is that if you have two frequent words in a document, just by chance, if both of them are frequent, they are also likely to appear together frequently, just by chance. So a collocation is a pair of terms that appear together more often than you would expect just by chance. So you try to address the fact that two common words, they will also appear together just by chance, just because they are both very common. So you may just consider elements next to each other or with a number of elements between them, like we did for collocations. And you may focus only on adjectives and nouns, or nouns only, or verbs and nouns, or verbs and adverbs. You may look at these specific pairs. How do you compute a collocation? How do you know more often than what you would expect by chance? You do a bit of statistics. You look at how many occurrences you have, what we call the observed count, and you compare to the count that you would get just by chance if these two terms, they would appear independently from each other. How do you do that? In stats, if you have seen that, that's a chi-square test of contingency table. Very, very common contingency statistical test. So you do a bit of statistics to try to extract the pairs which really matter in a way. And then you can do exactly the same as before. You may consider a collocation network. And you may have more than two terms as well. It's also something that you may do with a bit more statistics. So you will get things which are a bit different from the co-occurrences, because you will only keep those co-occurrences here where the words they appear more than where the fact that these words appear together is really meaningful. It's not just the result of chance. All right. Here you have the most relevant collocations of lemmas. It's not a graph, it's a table. It's a graph, it's a bar plot in Frankenstein. And when you measure how strong the collocation is, you have various measures. One measure is what we call point mutual information. So the larger the value, the stronger the collocation. What do you find? Albertus Magnus. That's the name, first name, last name. So of course they tend to appear very commonly together. It's very uncommon to have Albertus without Magnus and vice versa. Or Mont Blanc, Mont Blanc. Or Cornelius Agrippa or Soros Werther. These are names. So it's not very surprising. But what is interesting is that you have gigantic and stature. These go often together. Sum and money. Immutable law, or branch of natural and philosophy. or chemical instrument, or natural philosophy, or breaking ice, or grasp neck. So you may also learn something interesting here and slightly different from the simpler co-occurrences. That's what you may try to do. If I look this time now at plot summaries of Hong Kong movies, we also find interesting stuff. Kung Fu, martial art. You never have basically Kung without Fu and Fu without Kung. So of course you are going to get a very strong collocation for these two terms. Martial and art, fall and love, bad and guy, commit and suicide, antique and dressing, nursery and rhyme, traffic and jam, click and rate, man and tat, bowling and alley, large and sum, triad and leader, jade and tablet, gang and member, police and officer. So once again, you learn more about your documents with something by looking at this carefully. The numbers at the end is the value of another measure of how strong a collocation is. In the previous graph, I showed you that you can use something that is called point mutual information. But you may also use something that is called log frequency biased mutual dependency or something like that. I don't want to enter into the mathematical details here, but just understand that these are different quantitative measures of how strong a collocation is. And the higher the value, the stronger. So here, when you have minus 9.91, you see if I drop is next to minus 10. So it's the exact value, and you have the bar plot. So you see here we are minus 10, 11, 12, 13, 14. Here is minus 14.35. So it's just to represent the numbers. You can see here something weird. Doesn't. How come I have this? These are grammatical words. I should have discarded them. That's just one example that serves as a reminder that sometimes the analysis doesn't work perfectly. And for some reason, in some cases, doesn't and to have been considered as something like a nouns or a verbs or something. And it should have been discarded, but it was not. And then we have this. We should not pay too much attention to that. It can happen because the processing step, the pre-processing is never 100% perfect. That's okay. One error in many, many terms, acceptable. So of course, these terms are very different from these collocation and terms. They tell us about the differences as well between these different documents. Frankenstein, plot summaries of Hong Kong movies. Okay, I'm done with this one, and then we will finish for today. So you see, you can extract frequent co-occurrences. You can extract frequent terms. You can extract frequent collocations. But the connections between terms for these co-occurrences or these collocations, they are not explicit. There is no algorithmic account in any way of why two terms they often appear together. It's just something that is detected by the algorithm, but the algorithm cannot understand that Mont and Blanc, it's Mont Blanc. Yeah, it makes sense because it's the famous mountain in the Alps. You as the interpreter, as the person who pays attention to the outputs of the algorithm or who pays attention to the network, you are the one who is going to assign meaning, who is going to further understand what is going on. So it is our task as human beings to assign meaning to these lexical patterns. Sometimes it's very easy, sometimes it's not easy, but it can shed light on the content of the documents. That's what matters. To answer Emmanuel's question, when you look at point mutual information, the values are always positive. When you look at this one, it's a log frequency you take the logarithm of small numbers, and then you end up with negative numbers. Once again, you need the exact mathematical formula. But it would be hard to understand without digging quite deep. These are just measures to quantify how strong a collocation is. There are many ways to do that, but these are some of the options. So some of the measures are positive, some are negative. That's just the way it is. I'm not an expert in that, but if you want, you need to read more about that. You can find that online, of course. That's just different measures. There are yet others, actually. There are at least like 3 or 4 or 5. So you see, these are some approaches that you can use to start to work with a document. That's what, I mean, it's time to stop. It's quite late and I'm start to feel pretty tired after 3 hours. So if you have some more questions, please ask them now. I try to answer now. Otherwise, we will meet tomorrow, of course. We will continue with part 3 and part 4. And then I can show you what you may like. We can try to play with that. I can use the software I have already shared with you in a previous email. And then you can see that, yeah, you can see how what we may try to do. We can explore a few things together, okay? So that you see all of these things like more in practice. Is that okay? Clear enough? Interesting enough? Same as what I've told you 20 times, right? We are not face to face, so I don't see you. I try to share stuff that I hope you find interesting. I'm sure that for some of you, it may be easier to see how it could be relevant for what you do or what you plan to do. Maybe you want to do a PhD later on, or you are actually already doing a PhD, and you find out, oh, maybe I could use some of these things. That's my hope, right? But it's hard for me to know precisely. Is it possible, Emmanuel, to analyze combinations of more than 2 words? Yes. 3 words, 4 words, that may also be possible. No problem. That's totally possible. Slightly more complex, the algorithm, but no problem. Yeah, basically no problem. What we call n-grams, right? Like b-grams, 3 grams, n-grams, more broadly speaking. But then if you look at all the possible quadruplets, you may end up with a large number of elements. Then it becomes maybe a little bit too much, but you may still look at the most frequent ones or the strongest collocations, and that may be interesting, of course. Yeah.
Yeah, so Mohammed, just
yeah.
I want to get your idea. I do have a big data set of conversation of COVID patients here in Rwanda who are being treated at home. So, and I'm having about 20 million of conversation of those kind of people. So,
when you say conversation, is it like a text messages or is
yes,
it like
text messages? So the way it works, like those people who are infected with COVID at home, there are people who are in charge of contact tracing and the people who are in charge of supporting them at home.
Sure, yeah.
So then whenever they have a problem, they do send SMS that's I'm not feeling okay, I have this problem, I need this, and they came to support and so on.
Yeah.
So I would like to just get your insight on how to go from that, because my interest is how to use these techniques that we are learning to analyze those data, because I not analyze it, and we're having a bunch of them.
Yeah.
So what is your thought about that?
I mean, there are many things you may try here, right? It depends how far you want to go and stuff. First, you need to find like, what is the best document for me? Maybe if you have so many messages, if I understand that maybe one conversation consists of maybe 20 or 30 messages on average or something like that, maybe you want to consider one conversation is one document, okay?
Okay.
And then maybe you could start by looking indeed, I mean, first thing first, what are the most frequent terms? Of course, some terms are going to be too obvious, right? Okay, COVID-19, okay, it's going to be at the top, but you don't need really to pay attention to this one because it's too obvious. But then if you look a bit further down the list, maybe you can already start to know what are the most frequent elements. Then you might look also at co-occurrences and collocations that may start to tell you a little bit more about the kind of things people are discussing. You may, since it's SMS and stuff, the language might be a little bit more colloquial, right? So then it might be difficult to do morphosyntactic analysis. And additionally, if it's in Kinyarwanda, for instance, you may lack the tools to do that. However, if you have one conversation, you may still do some kind of bag of words. You may discard, you may keep only the most frequent terms. You may try different things, and then you could try to do topic modeling. And then you may be able maybe to classify, cluster rather the different conversations into a number of groups. That could be interesting because then you will know what are the different things people are asking help for. You could kind of try to detect in these conversations positive and negative words. And you may create lists of such positive and negative words in Kinyarwanda and try to detect them. And maybe that could tell you that some conversations are more positive, some conversations are more negative, and you might be able to rank them in terms of intensity of these sentiments and look at the most extreme ones where people are really happy, ones where people are really unhappy or very scared or not scared. And then by reading more about these extreme cases, you may know a little bit more like what are the most difficult challenges or the cases that could be best addressed by the people. You could focus, you could distinguish between the messages from the helpers and the messages from the people who are sending messages to receive help. You could distinguish between the two, and you could do separate analysis. You could do a joint analysis, and you could compare them. You could see whether you have cases where the people asking for help, they tend to use like quite negative terms, but the helpers, they tend to use positive terms. And what does it correspond to? Well, I'm just throwing stuff at it appears in my mind, but it gives you an idea that hopefully that there are quite a number of things you can do. Does that seem the case to you?
Yeah, that's very helpful, and it's really helped me to think on how to go with this. Of course, it requires some expertise and practice with this.
Yeah, a little bit more, but it's like stats. What I often tell people about stats is that you can do very good stats, very interesting stats, without using crazy, generalized linear regression with smoothers and stuff like that. Observing your data, and that can mean using simple tools like co-occurrences and word frequencies and stuff, and contrasting like the word frequencies for the helpers and the people seeking help, doing contrast, using simple things, you can already discover a number of interesting things. Then if you can go further, the better. But if you cannot, I mean, I'm very confident when I say that you can already learn interesting stuff.
Yeah, no, thank you very much. That's very useful.
Sure, no problem. Emmanuel, what does provide a good representation of data between document matrix and bag of word representation? So when you have a document term matrix, you are using a bag of word representation. That's kind of the assumption, because you look at the terms across the documents and the order in the different documents kind of disappear. So I'm not sure how I should answer this question then. So either maybe you can try to rephrase it, and I'm not sure if other people have questions. Just let me know. I can take a few more minutes, and then, well, then you can also think of more questions at home or in the afternoon, and then you ask me, of course, the questions tomorrow. No problem. When do we use each of them? Okay. If you do sentiment analysis, maybe the documenter matrix is not the best one. When you do topic modeling standard approaches, you need a DTM. Like the functions you may use in R, for instance, they will take a DTM as their input. So that's when you use it. And bag of word is quite related to this documenter matrix. So I would say topic modeling, and you might use them in some other, like just if you want to compare documents, not with, I mean, you may compare documents with documenter matrices and bags of words, and it's not doing topic modeling, it's just another approaches based on the matrix. For instance, if you take the vectors for different documents in terms of the words, you may compute some sort of distances with a cosine distances or stuff like that. They are things you may try. If you have the documenter matrix, you may also identify sets of shared words across documents, stuff like that. Topic modeling does a bit of this actually, but it's a different approach. So yeah, trying to understand the content of document from a broad perspective, documenter matrix is one simple tool to do that. You may also do what we call TF-IDF. I think I will tell you about that tomorrow. Let me see. I don't tell you about TF-IDF here. Okay, I'll remember if you want the manual tomorrow, you just said, okay, you told us about TF-IDF. Can you explain more? And this is something you compute with a document matrix. I'll tell you about that. But maybe right now I don't have the time. It takes more than 2-3 minutes. Anything else? Or are we good for today? Maybe we can continue tomorrow. That will be fine. So I will stop the recording right now.